Ay, mira que sí que lo conozco. Hi. So first of all, thank you very much for coming here today. Thank you very much for coming here today. My name is Aida, and I work as quality analyst in ThoughtWorks Barcelona. I've been playing the QA testing role for around 8 years. Like most of the people, I started by doing manual testing, very exciting. Then I did lots of automation. At some point, I've been also managing a team of QAs. And nowadays, I'm working with my team, developing while playing the QA role. So that's all about me. But before going with the talk, I wanted to show the slides of the sponsors. And I wanted to ask you for an applause, because without them... without them, this wouldn't be possible. So thank you very much. And I'm going to start with the talk. So I wanted to start the talk with this slide. And what do we have in here? Here we have a Jenkins job that is executing an automated testing suite. And this testing suite has hundreds of end-to-end UI tests. And as you can see, all of them are red. So please raise your hands if you've been in a situation like this. I've been there, me myself, yeah. Okay. Okay, don't be ashamed. So the worst thing about this situation, and believe me, this already looks pretty bad, is that when you finally get to a green build, like in this slide, you start wondering yourself whether you did something wrong. Maybe someone changed the Jenkins job and I'm not seeing the results correctly. Maybe the tests are not even being executed. Whatever, you don't trust your tests. So in order to understand how did we end up in this situation, I would like to go back in time and see what happened in the first place. So how did we end up in here? Imagine you work in a company that has a web application and you've been asked to develop a new project. And you start thinking, how are you going to implement it? The language, the framework, the testing strategy, release strategy, everything. So because this talk is about testing, I'm just going to focus in the testing part. You with your team gather together and you start thinking, how are you going to implement those tests? And suddenly someone says, okay, I know you need an integration test, they are really good, but they are not going to give us the confidence that we need. They are not going to tell us if the user can use our application properly. If we want to make sure that they can, we need to implement end-to-end UI tests that go through all the stack. And we need to test the different user units in this way. So your team thinks about it and, yeah, this kind of sounds reasonable to everyone. So, yeah, this is the testing strategy that you're going to be implementing. This is the one that is going to give you the confidence to go to production. So at the beginning, you start with the project, and everything goes fine. You start implementing your tests just as you define that strategy, and everything is green, your tests are really fast, and you have confidence in what you're doing. So what do? You implement more and more of those end-to-end UI tests. You also implement a few unit and integration tests, but you focus in those end-to-end tests because they are the ones that are going to give you the right confidence, remember. But one day it happens. One test fails. So you take a look at your test, you try to reproduce what went wrong because you want to fix whatever failed. However, you have a problem. You don't know what went wrong. You cannot reproduce the error. So at some point, you decide that you don't want to waste more time with this thing, and that you are going to hit the run button and hope for the best. And, well, luckily it goes green. Not a big deal. I can keep on with my work. Well, you didn't know at this moment, but this is exactly when everything started going wrong, because you had a flaky test and you accepted that situation, and that was fine. So what is going to happen with time is that you're going to have more and more of those failing tests. But as long as you press the run button and they go green, not a big deal, that's fine, until one day they don't. So you press the run button again and again and again until they go green. And without even realizing, you ended up with hundreds of tests and a build that is never green. So at this moment, you regret that time you pressed the run button without spending the necessary time fixing your test. The problem is now it is too late because you already hate your test. You are like this on fire, hating your test so badly. They are not giving you the right feedback loop because they are too slow, because you have too many of them and they go through all the layers, and they are brittle, they are failing for no reason. And the problem is that right now these tests are very expensive, and the maintenance cost is really high. So you start wondering yourself whether you want to keep those tests. However, yes, you want to keep them because you've been promised that with those tests you are safe to go to production, and you don't want to really lose this safety net. So it is a pretty tricky situation, the one that we have in here right now. Cool, so now we know how did we end up in the situation that I presented at the beginning of the talk. However, we don't know how can we avoid this situation in the first place. We know that we shouldn't have pressed the run button, but there are probably more things that we could have improved or done better. And one of them is a testing strategy that the team decided to follow. And this is exactly what I'm going to be talking about in the next slides. So in order to do this, I would like to first present the concept of the testing pyramid. Traditionally, the testing pyramid has been the tool used for planning the testing strategy for your project. So the testing pyramid was first introduced by Mike Cohn in 2009 in his book Succeeding with Agile. And what he says in his book is that in order to have an effective testing strategy, you should automate at 3 different layers. So at the bottom, we have unit testing, which should be the foundation of a solid testing strategy. Unit tests are narrow, and when they fail, they give you specific data about the failure. They are also super fast, and that's why you can have many of them, and they are going to give you a really quick feedback. Then in the next layer, we have service testing, which I'm going to skip for the moment, and I'm going to jump to the top of the pyramid where we find UI testing. So UI tests, we just want to have a few UI tests, and this is because they are usually slow, expensive to write, and time-consuming. So, yeah, and another thing that happens with UI tests is testing through the UI can be very repetitive because you could have the same step repeated through many different tests. So imagine that in your application, you always have to perform a login. So that login step will be in every single of your tests, which is probably something that you don't need to do. So although there are many behaviors that we want to test at the UI level, not all of them need to be done at the UI level. And that's why we have the service layer. Here you can test all those behaviors, but disconnected from the UI. And here what you're going to achieve is that your tests are going to be faster and less brittle. So the problem was that many companies were completely avoiding this middle layer, and they were filling the gap with lots and lots of UI tests. And this is exactly why the testing pyramid came in order to suggest how much testing you should be doing in each layer to keep a good coverage. So if you go back to our example, you think about it, we were not following this testing pyramid. Instead, what we had is something like this. This is called the ice cream cone or the inverted pyramid, and it's a very well-known testing pyramid anti-pattern. The problem here is that you are doing lots of UI tests, and as we saw before, testing extensively through the UI is really expensive. So this pattern is commonly seen in companies where the testing effort is pushed either to a different QA team or to a QA person that is working inside the team. And probably this person is taking a lot of care of those higher level UI tests, but they probably don't have visibility about these lower level tests. And as we can see, because of the shape of the pyramid, no one is taking enough care of those tests. The other anti-pattern that I wanted to show is the hourglass. So here the idea is a little bit different. You have lots of unit tests and you have lots of UI tests. So probably a lot of the logic that you are testing at the unit level, you are also testing it at the UI level. So you could have lots of repeated tests, which you probably don't want to and don't need to. And you are not taking care of this middle layer. And again, as I said before, you have lots of UI tests which are expensive. So this pattern is often seen in companies where both QAs and developers, they both take care about quality and they both work doing tests, but QAs focus in those higher level tests and developers in those lower level tests. And this suggests that they are probably not collaborating enough, because if they were, this probably wouldn't look like this. The other thing that I wanted to show is the Swiss cheese syndrome. This is not known as a testing pyramid anti-pattern, but it's definitely something that you want to be careful about. So the idea here is that during the development of an application, there are several testing activities that take place. We already saw unit testing, service testing, UI testing, and it is unlikely that one of those single testing activities covers the whole application. So here is where we have the similarity with the Swiss cheese. We have holes in our applications. So in this image, these slices, each one of these slices, they would be the testing activities, and the holes is what I said, the holes in your coverage. So this same idea was explained in Mike Cohn's book in a little different way. So what he says is that the testing effort that you put in one layer should be affected by the testing effort that you put in the other layers. And in order to be able to do that, you should have a complete view of all the testing activities. And if you don't have this complete view of all the testing activities, you could have this tune-up that goes through all the layers and therefore a potential bug that could arrive to production. So, with the testing pyramid, we have learned two very important things. The first one is that in order to have an effective testing strategy, you should organize your testing effort based on the testing pyramid in order to have the right amount of tests on each layer while keeping good coverage. And the other thing that we've learned is that to have a complete view of all your testing, you need to have a complete view of all your testing activities. So I want to talk a little bit more about this one. So how can you achieve this if you and your team has this separate QA person taking care about testing and quality in general? So in order to explain this, I would like to talk about the different QA types. I'm going to talk about 3 different types. There are probably more, but I decided to talk about 3 based on how they interact with the team. So the first type of QA, they are members of a QA team. They belong to that QA team, and many times they physically sit together with that QA team. They are not involved in the development lifecycle. Usually they are given some requirements. They prepare some manual test script based on those requirements, and when they get the code, they execute them. As I said, they perform manual testing, and the process is very waterfall because there is a very well-defined development phase and then testing phase, then probably bugs, more testing, and so on. So working in this way has some problems. The first one is the feedback comes too late because we have this very defined development phase and testing phase and so on. The communication and collaboration is probably something that could be improved because the people that is doing the code and the people that is testing the code, they are not working together. Testing becomes a bottleneck when you work in this way, plus the work is very repetitive. It's actually not very exciting working in this way. So, because there were these problems, when Agile came in, QAs started working in a different way. So, we had QA 2.0. This type of QAs, they are members of a cross-functional team. They sit with their team. They are involved in the development lifecycle from getting the requirements until the application goes to production. Here they perform both manual testing and automated testing, but this higher level automated testing. And the process, although it's meant to be agile, it feels like a mini waterfall process. And this is because it is a waterfall process inside each story, because inside each story you have this very well-defined development phase, testing phase, bugs, blah, blah, blah. So the problems that we find with this type of QA is, well, the feedback has been improved. It comes earlier, but it is still late because it comes at the end of the story. The communication and collaboration has improved, but it could be improved a little bit more because we still have QAs taking care of these higher level tests and the developers taking care of those lower level tests. Testing is a bottleneck still, and this becomes more visible when it comes to manual testing. And well, the work, it is a little bit more exciting, so we don't have that problem here. So because we still have these problems with this type of QA, some people and some companies decided to work in a slightly different way, decided to evolve. And that's why we have the third type of QA, QA 3.0. So these QAs, they work with a cross-functional team. They are not only sit with them, they work with them. They are still involved in the development life cycle. This is the same thing. But here the main difference is that they are not the ones performing the testing. The team is the one performing the testing. Everybody's thinking and actually doing the testing. And this is what it actually feels agile, because you're thinking about testing before even developing. So with this type of QA, we still have some problems. We've solved the previous ones, but we find new problems. And this is, the first one is the learning curve. Developers need to learn how to test, and QAs need to learn how to develop. This is hard by itself, but some people is also not willing to do it. So this is another added complication. And then we have the fear. Developers have fear because they don't have this person like doing the final check. So maybe I am going to bring it back to production, and I don't want to do that, of course. And many QAs I found that they fear. They start questioning themselves, like, what is the value that I'm bringing to the team right now? Because I'm not the person in charge of quality. Everyone is thinking about quality, so what is the value that I'm bringing? And now I have to code, but I'm not even good coding because I just started learning. So yeah, these are the problems. And the things that I found that can mitigate those problems are applying good coding practices. And here I can recall TDD to make the process even more agile, and also pairing to mitigate the learning curve and also the fear, and this helps a lot. So, going back to the different types of QAs, and going back to the question that I was asking, which was you should have a complete view of all the testing activity. This QA is not going to have a complete view of all the testing activities because it's only thinking about performing manual testing and doing manual testing. This QA is not going to have a complete view of all the testing activities because they perform manual testing and the higher level test, but they don't have visibility about the lower level test. This is the type of QA that is going to have the visibility of everything. And not only the QA, but also the developers, because they are working together in doing all the tests and all the code, so they know what is going on. So, okay. I've been talking a lot about the testing pyramid, and now we know, in the example that I was presenting at the beginning, now we know that we were focusing in the wrong testing strategy. We were doing lots of end-to-end UI tests, and that's not what we should be doing. We should also be doing unit tests and service level testing. But even if we did that, even if we correctly applied the testing pyramid, I feel that this wouldn't be enough to get to the confidence level that we want to get. So I'm going to be talking a little bit more about the testing pyramid. So this is the testing pyramid that Martin Fowler showed in an article that he wrote in 2012 in his blog. And with this testing pyramid, he transmits the same core idea of the testing pyramid, that you should have lots of unit tests because they are fast and they are cheap. You shouldn't have many UI tests because they are slow and they are expensive. So while he thinks this core idea is right, he mentions two very important ideas in his article. The first one is that the common problem is that teams conflate the concepts of end-to-end test, UI test, and customer-facing test. So many times in companies, I found that they think all the UI tests need to be end-to-end, and that all end-to-end tests need to go through the UI. And you will see in a while that it doesn't have to be in this way. The other important idea that he mentioned is that there is much more to say about building a well-balanced test portfolio. So if you think about this, when the testing pyramid was conceived, applications were monolithic, and it actually made a lot of sense to test them in this way. However, nowadays we have microservices, we have distributed systems, and this approach, it just feels insufficient. So I feel that most of the problems that we find nowadays when we are executing our testing suite come from these two ideas. And I'm going to start developing a little bit more the first idea, the confusion between end-to-end test and UI test. And in order to do this, there is a talk that I really like, which is called Subsecond Acceptance Test, and is given as like ASI. And in his talk, he starts with this same testing pyramid. And one more time, he mentions the core idea of the testing pyramid, that you shouldn't have many UI tests because they are slow and they are expensive. So what he says is that you may have not realized, but there is a hidden assumption in what I just said. And this is that the UI tests are slow. It is not true that we want to have a few UI tests. What it is true is we want to have a few of the slow and painful tests. So the thing here is that if UI tests weren't that slow and painful, the testing pyramid would probably look different. And this is why he presents a new version of the testing pyramid, which is the love-hate relationship pyramid. So the thing here is that what he says is that you should have lots of the tests that you love. You should have just a few of the tests that you hate and make your life miserable. And you should be somewhere in the middle with the tests that you either hate or love. And he calls them the meh-test. So what you need to understand is that which are the characteristics that makes you love a test so that you can have more of those tests. And this is the speed. Okay, you want your test to be super fast. And determinism, you don't want your test to fail for no reason. So if you realize this is representing exactly the same idea of the traditional testing pyramid, but without making any assumption. And while he thinks it's true that UI tests are slow, he believes this is because they haven't been well thought. And he's going to explain this very well with the following example. So imagine once again, we have a web application. So this web application typically will have the following layers. A database to store your data, a repository to be able to talk to your database, your logic, an API, the network, a client to talk to your API, user interface, maybe with React, your DOM, your browser, something to talk to that browser, probably Selenium, and your test. So if we want to make our tests faster, we need to understand what is making them slow. And in the case of the tests, this is usually because they are I/O bound. So here we have the database, we have the network, and we have the browser. So what can we do to make them faster? And he suggests the following things. We could remove the database and use an in-memory database, and this is going to improve the speed hugely. We could completely remove the API part and connect the UI to your domain logic. Of course, you can only do this if you are using the same language in the front end and in the back end. If you are not using the same language, you can just completely mock the back end. And you could remove this browser part and talk directly to the DOM. Or you can do all of them together, or just a few. You can do a combination of them. So this is about the speed. But we also have brittleness that we want to improve. So what is making our test brittle? Well, first of all, you have all these layers. So the chance of something going wrong is just higher. Then you have the network, and the network can be slow, so you can have timeouts. And then you have the browsers. The browsers are asynchronous, and different parts of the page load at different times, timeouts again. Plus you have animation, some pop-ups, and many, many other things that make testing through the UI just really, really difficult. So if you realize the same things that are making our test slow are making them brittle. So the same solutions that I mentioned before also applying here. And if you realize what we are trying to do with all the things that I was mentioning is moving the UI test down the pyramid. UI test doesn't have to be end-to-end tests. They don't have to be at the top of the pyramid. So if we do so, how confident do we feel with our test? This is a big question. And the thing is that we are trying to get different types of confidence, all from the same type of test. We want to know that our logic works well. We want to know that the UI works well. We want to know that it's compatible with different browsers. We want to know that we can communicate with the other services properly. All of those things from the same type of test. So the big question here is that why don't we get those different types of confidence from different types of tests? And this kind of leads me to the next thing that I wanted to discuss, which is that the testing pyramid is simplistic. So I need a bit of water. So here what I want to do is present a proposal of a UI testing pyramid. And at the bottom we will have a unit test, as the traditional testing pyramid says. And well, nowadays with modern UI frameworks like React and Angular, it is possible to unit test the UI, so just take advantage of that and implement lots and lots of unit tests. In the next level, of course, we have UI integration tests, and in the example that I was explaining before, those were UI integration tests. I already explained the different ways in which you can do that, so I don't want to expand more in this one. Then we have UI end-to-end test. Here you probably want to go through the browser and test against the real database. And this is expensive, so remember that you just want to implement a few of those UI end-to-end tests. So with all of these tests, the only thing that I'm testing is functionality. But there are probably many other things that you want to check at the UI level. And those are typically the look and feel of your UI and the compatibility with other browsers. So here we have visual testing. And visual testing is about that. It's about making sure that your UI looks well. So I know I did a few different types of visual tests, and each one of them is going to give you different types of confidence. So the first type that I wanted to discuss is screenshot testing. So basically in here what you're doing is using a tool like Selenium to open your browser and navigate to the page that you want to take the picture. And you take different pictures of your application, and then you compare those pictures with previously taken pictures, and if they differ in an unexpected way, the tool will let you know. The other type of visual testing that you can find is layout testing, and layout testing is more about making sure or checking the web properties of web elements in isolation, and the main difference with screenshot testing is that here you are checking the web elements in isolation, and with a screenshot testing, you are testing the whole composition of the page. And the other type that I wanted to mention is DOM testing. So DOM testing is pretty much like a screenshot testing, but instead of comparing a screenshot, what you are comparing is the DOM. And here you need to be careful. The confidence is lower with a screenshot than with a screenshot testing. And this is because what the browser is rendering is not the DOM, it is the rendering 3. So here there could be some little differences. And another thing that I wanted to mention with visual testing is that probably your application is responsive, so you may want to run your visual test with different screen sizes or viewports. Then we have browser compatibility. So this is about making sure your application works well in the different browsers. And as you can see, I didn't put this as another layer, and I rather put this as another dimension. And this is because it applies to all of the other type of tests. So in order to run your browser compatibility test, you may want to take all those tests, or a subset of them, and run them in different browsers. And well, this is the testing pyramid that I wanted to propose, the UI testing pyramid. But if you feel that in your project there are more things that are important for you, just go ahead and include them in your pyramid. So I've been talking about a lot of theory, and now I wanted to show a real example of how I applied the previous testing pyramid to the project I was working on before. So the project was a form builder, and my team was in charge of filling the form and submitting the results. And as you can see, this application had to work in mobile as well, so it was a responsive application. So first we started doing the UI unit tests, and we decided that we would test these web elements, the look and feel, and the interactions. So those web elements, they came from a design system, and the look and feel was already tested in there, so we didn't have to take care about that part, and we focused in doing the test for the interactions. Then in the next level we have UI integration test, and this is the configuration that we decided to follow. We would go through the real browser and we would completely mock the backend. And this was the configuration that was working for us. It allowed us to test lots of behaviors super quickly and with good results. Yes, and then so this was for integration. For end-to-end tests, what we did is we just implemented a few tests, I don't remember, 2, 3, removing this mock and hitting the real services. The other thing that we did is browser compatibility testing. This part of the application was critical, and it had to be working in as many browsers as possible, browsers and devices. So in order to decide in which browsers we were going to be testing our application, we first needed to gather data. When we gather data from 2 different places, we gather data about the usage of our tool, and we also gather market data. And there is this really nice web page, StatCounter. Here you can see the usage in different browsers, devices, you can filter by country, you can do lots of things. So taking all this data into account, we decided that we will run our test in Chrome, Firefox, Safari, Microsoft Edge, and Internet Explorer. So we took, yeah, that's a lot. we took all of our integration tests and we ran them in all those browsers, but Internet Explorer 11, because it was kind of impossible to make our Selenium work with Internet Explorer 11. So we just took that part manually. And another thing that we did is parallelizing the execution of the test. Otherwise, it will increase the build time a lot. And as I said before, our web application had to be responsive. So we took one of those integration tests, just one, and the most complete one, and we ran them in an Android device and an iOS device. And you might be wondering, why just one test? Well, because testing against real mobile devices, it is really, really expensive. And we decided that this was enough to get to that confidence level. And it worked for us. This is the more important thing, like just checking if it works for you or not. And the last thing that we needed to do is visual testing, so our application had to be pixel perfect. That was a requirement for the CEO, yeah, because he was a designer. So, so we used this tool. It is called Applitools, and what we have in here is the baseline image and then the screenshot that you take when you run your test. So we had a few images that we wanted to test in this way, and here we also run them in the different browsers that I showed before. And the other thing that we do is we also run them with small viewports. And this was to emulate mobile devices. So again, why different viewports and not a real mobile device? Because this was faster. And again, it allowed us to get that confidence level. It worked for us. So a lot of UI testing. I'm going to switch the topic a little bit now, and I'm going to talk about microservices testing. So in 2014, I think it was, Toby Clemson launched a really nice deck about testing strategies in a microservice architecture. So basically what he's doing and what he's suggesting is adding more layers to the traditional testing pyramid in order to overcome the complexity that microservice architecture brings. So these are the layers that a microservice would typically have. We have the domain with the logic, the application with our services, and the infrastructure with maybe a client if we want to talk to an external service, maybe a repository if we need to talk with a database, and a controller if we need to receive calls from the outside, typically a user interface. So the main thing here is that in order to have a proper testing strategy, what he says is that you should test each of these layers, between these layers, and every communication with the outside. Okay? So taking into account these ideas, he proposes the following testing pyramid. At the bottom, as usual, we have unit testing, and with unit testing you will have a pretty good coverage for your components in isolation, but you don't have no idea how they work with other components. So in the next layer we have integration testing, and here the idea is testing each integration that your application has with everything that lives outside your application. So here we have the integration with the database, or the integration with that external client. And here the most important thing is that you should be testing one integration point at a time. And the other thing is that you shouldn't be testing the other service. You don't want to test the database. Someone else took care about that, hopefully. You should be testing only the basic success and failure paths. In the next layer, we have component testing, and with component testing, you will have a pretty good coverage for your whole service. This will cover all the layers. And here you have a few options. Here you may want to do real HTTP calls and hit the database, or maybe you decide to just avoid the network and use an in-memory database. Again, this depends on you, on the confidence that you need, and which are the options that you have. So with all these three layers, you have a pretty good coverage for your service. However, your service will probably talk to other services, and you need to test that communication. So we have a few options in here. We can do contract testing, or we can do end-to-end tests. So I'm going to start with contract testing because these are lighter. Contract testing is about testing the contract that two services have. And here again, it is very important that we are not testing the functionality of the services. This is already tested in here, so we can forget about that. We only want to test the different contracts that two applications have. So here we have a few options that I know. We have consumer-driven contract testing. So here the idea is that it is the consumer, the one defining the contract, and then the provider, it is tested against that contract. The other option that we have is document-driven contract testing. So here, basically what you do is you document that contract, and then you test both the provider and the other one, the client, consumer, thank you, against that contract. So I really like that one because you make sure that your documentation is up to date. Then again, we have end-to-end test. And yes, you can have end-to-end test for your API, for your backend. Just go ahead and implement a few of them, and just a few. And at the top of the pyramid here, he also included exploratory testing. And although there is not unscripted tests, I think it's a really nice idea to include them in your pyramid in order to show that the effort that it takes. Okay, I did a spoiler. So this was all about microservices testing. What about mobile testing? Well, of course, someone thought about the testing pyramid for mobile testing. So the thing about mobile testing is that it is really, really complex. Here you do not only need to take care about those UI aspects, you also have the hardware, the network, the different operating systems of the devices, and the version of the different operating systems. So it is really complex. So there is a deck that I read that it is really nice, this one. And what they do is, he proposes this testing pyramid for mobile. So at the bottom, you have testing against browsers, of course, simulating or emulating changing the user agent to emulate a device. In the next layer, you have testing against emulators, and at the top, you have testing against real devices, because these are going to be the most painful and slow of the tests. So I'm not going to talk more about mobile testing because, this is a really complex topic and I haven't really done much of it, but I just wanted to give you a feeling of what is the thinking around mobile testing and the pyramid. And this is the last pyramid that I'm going to show. This is the DevOps Hourglass. This was presented in the book A Practical Guide to Testing in DevOps, which was written by Katrina Kukli. So until now, I've been talking a lot about testing prior to production in development environment, but what do I know about my applications once it reaches production? Well, what they do here is adding 3 more layers to the traditional testing pyramid, and those are logging, monitoring, and alerting. And they are inverted because you should have lots of logging, less monitoring, and a bit of alerting. So this as a whole is known as observability, and it's something that is becoming more and more important nowadays. And this is because nowadays applications are really, really complex, so it is just hard to test everything. We shouldn't aim to test everything. We need to acknowledge and that there are bugs that are going to arrive to production. And this is fine. What we need to do is implement the tooling necessary to be able to detect those bugs as soon as possible and to be able to do something about them quickly. So this is what you should be doing. So as I said, this is the last pyramid that I wanted to show. There are more things that I didn't speak about, like production testing or security testing, performance. What happens with those? Well, if those are important for you, and they should be, you should include them in the pyramid or do a new pyramid for them, or just think about them. So conclusions. Okay, we've seen lots of testing pyramids, from the first one, MyConf testing pyramid, until the DevOps Hourglass. We've also seen some testing pyramid anti-patterns or things you want to avoid, and different ways in which QAs can work with the team. So the big question here is, how should testing be done in my team or for my application? Which of all the pyramids that we've seen should I apply, or how should testing be approached inside the team? Well, bad news. The question is the answer is that there is no answer. But I have some tips for you, or things that you can do to improve those. So the first thing is that you need to discover your pyramid, and in order to do that, there are some steps that you can follow. First, draw your architecture, and once your architecture is very clear, you can start drawing your testing pyramid. And you can take as a basis and as a starting point all the pyramids that we've seen. Then follow the core idea of the testing pyramid, which is have lots of the tests that you love and just a few that are a nightmare. Move the tests down the pyramid as much as you can. Move those tests down the pyramid because it's going to give you faster feedback. Have a complete view of all the testing activities and get different types of confidence from different types of tests. There are many different testing activities that you can perform nowadays, so just explore the different ways in which you can do that. And the last tip is that make your whole team own the quality. If there is a single person taking care about quality, the result is not going to be the best one. If everyone is thinking about quality, this is where you're going to get the best result that you can get. So the big question, going back to the topic of the talk, are UI tests dead? No, of course, UI tests are not dead. It is very important to test the UI, you just have to do it in a different way. What it should be dead is a testing strategy that relies only on doing end-to-end UI tests. That should be dead. So this is the resources that I've used for my talk. Many of the things that I didn't come up with them myself. It's just a recompilation of all those and do so. Thank you very much. Questions?
Yeah, let's go through that.
You can go Spanish or English. I'm fine with everything.
Well, thank you very much.
Well, I'm Spanish.
You talked at the start about QA 3.0 and about how with QA 2.0 you still have late feedback, you still have mini waterfall because you're doing development and then you're doing testing.
Yeah.
But with QA 3.0, are you suggesting that you don't do testing after development has finished, that all of the testing happens during development instead of afterwards?
Not all of the testing. I think it's about a little bit of testing, a little bit of development. I mean, the thing is that first you need to have this testing mindset, and this is going to help you when you are developing. And then, of course, you need to techniques to help that process. One of them is TDD. TDD is going to allow you to have this agile process. Of course, at the end, you will always have some acceptance testing phase, probably, but the smaller testing, you can do it while you are developing.
Okay, thank you.
When you were talking about contract tests, I think you mentioned that you knew 3 ways. I think you mentioned only 2.
Well, maybe I said 3, but I meant 2. Sorry, no, I was not missing anything. And I only know 2, but there are probably many ways.
And the UI testing that you shown in your project, how long it took?
The build time. The build time in total was 10 minutes. This includes test, building, and uploading to S3. Everything but deploying, which was a different job. And tests, I don't remember, maybe they were 6 minutes or something like that. I know it's a lot, but for UI testing, I think it's not that bad.
Hi, I have a question also about the QA 3.0. Does it mean that there's someone in the team that actually has the role of QA or something like that?
It could mean that.
And in that case, what are the responsibilities of this person? Because I see a contradiction that we face ourselves.
Yeah.
Everybody should be in charge of testing, but at the same time there's a person that should take more care of testing, and it's easy sometimes to say, I'm not going to do it, that person is going to do it. So what are the roles exactly of this QA person? At what point?
I can talk from my experience because this is how I work in my team right now. So I don't feel I have that responsibility alone. The whole team has that responsibility. So what we try to do, at the beginning what I try to do is with pairing, try to teach everyone how to do testing. Of course, at the beginning it's not going to be perfect, but you need to improve with time. So you shouldn't, this QA person shouldn't feel the only responsible of testing. And this is the fear part that I was talking about before. You have to stop having this fear. Everyone can do testing and everyone can do it well. So did I answer your question?
Yes, but maybe following that, does that mean that the moment you have taught the whole team how to do it, maybe that role is not needed anymore? In the same way that if a Scrum Master does the well job, then at some point you don't need it because the team itself can do it?
I'm not implying that, but maybe, I don't know. I think it's good to have one person that it is more experienced with testing. Otherwise, the others, of course, they can do it, but maybe if there is one person that has more experience with that, that person can teach the other people. I don't have an answer for that. I don't want to answer that. Yeah.
Thank you.
What about the web accessibility? Do you think it should be tested as well in the UI?
If it is important for your application, yes, it should be tested, of course, yeah. It depends, of course, if you are building for that, it should be tested, and you should include that in the pyramid.
Hello, I really loved your presentation.
Thank you.
Because it made me consider a lot of my attitude today. Yes, I think what is happening to us is that we are a small team, like 5 people in the team, and we have discovered this Cypress testing framework. I don't know if you know it, but as I'm saying, Cypress is a testing framework that makes you love testing again, no? And suddenly, everybody in the team has started doing testing and even TDD, because it's very simple to create a test, realize that it doesn't, the test is wrong, and then you do the development, and then suddenly you. But we are doing so all this testing, UI testing, and even end-to-end testing. And what we are confronting now is this first application this first slide that you showed, in which yes, we have random failures and time because of timeout, sudden timeouts, UI things, and everything. No? So. And I think I was the one that was saying, oh, but it's good, let's do more end-to-end testing and everything, because this is great. And we do at least some testing that before we are not doing, because I think unit testing also is more complex and everything. No? So my question is, I don't know if you have confronted something like this, but I know your whole presentation has been about this, and there is no right answer, but in a really short term, what do you think I should do, for example, on Monday, to start thinking, okay, maybe I was wrong, maybe we can do something. We have tons of testing strategies, so in a very short term, what do you think we could do to maybe move more down in the pyramid?
Well, I had this problem. I'm talking from experience, and I can tell you what we did, and maybe this can help you in your case. So when we had this problem, and at some point we decided, okay, we are going to do something about it, we started reviewing all the tests and getting the build green. Okay, and how do you get it green? It depends on the test. There are tests that you may want to fix, and this is not going to be easy sometimes. And there are tests that you may want to decide to move down the pyramid. So you may want to re-implement those tests in lower level. And this is going to require a lot of work, to be honest. Some tests we just decided to delete them, because if they are always failing, they are not going to give you anything, and yeah, you start just ignoring them. So maybe it is better to just delete them. So yeah, my recommendation would be like taking a look to all those tests, and this is like a lot of work, and decide what do you want to do with each one of those tests. Maybe you want to fix it and spend some time. Maybe you want to delete it. Maybe you want to move it to a lower level. Maybe just do a high-level review at the beginning, decide more or less what you want to do, and then have a project, like a long-term project, to be able to do something about it. And also for the new features, start doing it in a different way. I think this can help. It's going to be some work, but...
Thank you.
More questions?
Okay,
very much.
thank you.